Today we're going to talk about the law of cosines, and basically the law of cosines says this: if you don't have an opposite pair, use law of cosines in an oblique triangle. It's your default. Algebraically, I actually don't think it's easier to work with than law of sines. The other thing is that with law of cosines, you're going to see that sometimes that special case kind of gets washed under the rug, so you forget about the other triangle that could result from when you're using the law of cosines. So one of the rules I'd like you to stick with moving forward for the test especially is if you enter into a problem and do not have an opposite pair using law of cosines, stick with law of cosines all the way through. Okay, don't switch and move to law of sines even though it's easier. The reason is because from like just a teaching perspective from me, we may be missing a second triangle. However, I want to see that you know how to use law of cosines and all the different parts of it, which will result if you just stick with that one form. Okay, if you go to law of sines, stay with law of sines. Okay, if you take a look on the back, this is a proof. Do you have this on the back of that first page? On the back of the first page is a proof of law of cosines. Kind of interesting, something you might want to read through at some point if you really love math. Basically, it shows how if you take any triangle, you drop in an altitude, and you start kind of doing calculations that take you from one side to another, you can generate the law of cosines to figure out any of the sides in a non-right triangle. That's where what you're seeing on there, where it comes from. It's a very clear explanation. It's why we put it in there. All right, so you can check that out on your own. First thing I want to talk about is just some algebra of the law of cosines. So if you take a look up here, I have a bunch of numbers that I plugged in. And I started working my way down, and there is a very clear algebra error. If you look on the front of your notes, all the way on the bottom on the right, I did put the problem on there. I used to just do it as a warm-up, but I think it's a really good reminder of the limitations of your calculator. You do need to use your brain a little bit with these. So what do you think here? Where is the error? You may not know how I generated this equation, but you should be able to tell me the error in solving this equation. It looks scary, it's not. Where is the error? Think you found it, just raise your hands. I'm going to wait until we have about 10 people that think they found it. We're at 3, 4, 5. Probably want to use your calculators because these are some nice numbers. Years way before that. All right, let me see who thinks they found it so far. Raise your hands nice and high. This worries me. This would be an error you would have found in the prerequisite unit. An error all the way back at PEMDAS. 8. We're up to 8 people now. A couple more yet. 9. I think that was our 10th person. All right, anybody want to go out on a limb and explain what they think the error is? No, hands are up. All right, Becky, go ahead.
You subtracted the first one before you multiplied. Like you did like the first half and then you subtracted it when that's multiplied on the cosine.
I were solving an equation and it said 10 is equal to 6 minus 4x. Would you make this 2x? Why not? Why isn't it 2x? 6 minus 4 is 2. They're not like terms. Same thing is going on here. This is a number by itself. Number by itself. This is a coefficient. Yes, it's three things multiplied together, but it's like functions like a 4. In front of the unknown, which is the cosine of x. So we don't really know what x is, but that's considered the coefficient. So just like here, wouldn't I technically subtract 6? Yes? All right, so from an algebra standpoint, let's cross all this off for now. Boom, boom, and boom. And let's write what we should have done here. What we should have done is I'm going to do it over here. 4 squared minus 3 squared minus 8 squared is equal to negative 48 cosine x. Does that make sense? Bless you. Move the plain old numbers to the other side. I didn't change the form of them because you're going to be using your calculator to do these. So I think it just makes sense to see what the input to the calculator would be. Move the 3 over, move the 8 squared over. It's actually 3 squared. From here then, I would divide by the coefficient. So put all that in your calculator and figure out what the decimal is. And then I'm going to use cosine inverse of the answer of whatever you get from that. What do you get for your final answer? Put it all in. Squared minus 3 squared minus 8 squared. Hit enter, and then divide by negative 48. And then you take the inverse cosine of that. Answer? Error? Yeah. Everybody's getting an error? Okay, double check. Divided by. That's exactly why. All right, so why did I get an error? Because the number is greater than 1. Cosine, the ratio of the adjacent over the hypotenuse, always has to be less than 1. So that will generate an error. When you do the division, you got positive 1.19, which is greater than 1. So that does make sense that the calculator would generate an error. Okay, so we had two things that were going on. Number one was this. What you're seeing here is the first line is exactly what the law of cosines is going to look like in terms of numbers and work. Okay, so let's talk about law of cosines for a second. I'm going to skip through. I'm going to get to something that's important. Thought process. Here's your thought tree. Do you have right triangles? If you do, sine, cosine, tangent, or sine, cosine, tangent inverses. If you don't, the first question you're going to say is, do I have an opposite pair? If you do not have an opposite pair, default to law of cosines. If you have an opposite pair, then you're going to go back and use law of sines. So that's the big idea for all of the word problems in the unit once you create your diagrams. So if I look at example 1, I'm going to jump right into the example. You're going to say, well, you haven't even told us what the law of cosines is. You're right. I have not. Here's what it is. Okay. This is a formula. It is related a little bit to Pythagorean theorem, but here's the big idea. Yes, there are 3 versions of the formula. You don't need 3 versions if you remember the simple rule that whatever is isolated on the left as a side always matches to the opposite angle in the formula for cosine A. So capital A, small a, everything else just gets filled in. Other side, subtract 2 times the 2 sides. So the formula is really related to an opposite pair that you don't have in most cases. So if you notice here in example 1, I have two sides, I have an angle, I do not have an opposite pair, which means I have to go to law of cosines. So I'm going to be solving for side B. So I can say b squared is equal to a squared, which is going to be 5, side across from a, plus 8 squared minus 2 times 5 times 8 times the cosine of 77 degrees. This is ramped up a little bit because now we don't have linear equations, we have quadratics. So yes, we're going to be solving for b by using a square root, and we're only going to use the positive version of that. So you can go ahead and put all of this in your calculator, then take the square root of the answer and tell me what you get for b. Again, our unknown is this b. The whole right side in, hit enter, and then take the square root of the answer. The whole right side up is by itself already, right? So b squared is, you put the whole right side out and then take the square root of that answer. Notice in this one it's different from the warm-up problem on the bottom right. That's right, because you have to put the whole right side in. All of those are straight up numbers. Then you can take the square root of that answer to solve for b, which is already isolated on the left. Did you get 8.43? And then take the, once you get that, you take the square root of the answer. 8.43? Okay? Gabby, all right? Yeah? A little more tired than me. Yes? 8.43? Alright, so here's my note. It is strongly recommended that if you start with the law of cosines, that you stick to the law of cosines. Right? That's going to help you because there is no special case in law of cosines. So we're not going to switch out of it. We're going to leave it here the way that it is. We now know that b is 8.43. All we need to do is find one other angle. So let's do the algebra of that at least one time. Do you want to find angle C or angle A? Let's find A. Okay, so we're going to find angle A down here. So that means if I want to find angle A, my other side of the equation has to be 5 squared. Opposite pair have to be related here. So I've got 5 squared is equal to 8 squared point 8.43 squared minus 2 times the cosine of A. Now this is like the warm-up problem where we're going to have to use cosine inverse to solve. So in my calculator, I would put in 5 squared minus 8 squared minus 8.43 squared, all of which is divided by this product right here. question is, do you get 35.31 in your calculator? Can you enter it correctly? See if you can get it to match up that the calculator gives you that. Please. So now we're filling in the letters and resolving for side error. Okay, nope, you won't get in there. I'm gonna erase this so you can see everything. So personally, if I were using the calculator, I would put in the numerator, 5 squared minus 8.4, 3 squared minus 8 squared, or a variation of that. I would hit enter. Then I would divide by, and I would use parentheses, and I would type in -2 times 8.43 times 8 parenthesis closed. Get my answer, and then I would do cosine inverse of the answer. So I would do it in 3 steps. Yeah? Do the whole top, get your answer. Divide, and then I would do -2 times 8.43 times 8. Get your answer, and then I would take the inverse cosine of that ANS answer. All right, once you have this angle, 35.31, we then would simply subtract from 180. No, it's hot in here. I know, every day. All right, why don't you go ahead and try example 2. You can work with a partner, you can work by yourself, and then we're done. There's no other examples. This is it. Notice you have no opposite pairs in example 2. You have to use all cosines because there's no opposite pairs. And it's not a right triangle. Well, if you look at law of cosines, don't you have 4 unknowns? 3 sides, 1 angle. You have 3 sides. And whatever angle you solve for has to be that opposite pair to the one that's on the other side.
What? Let's find out. Age or I don't really know what this is. We find out acres. Oh, facts. Doesn't really matter.
Nope. Your assignment sheet. No one's not gonna do that. It really helps me. Are you abbreviating your decimals at all? Or subtract 60? The problem we have is you have to put A in.
Oh, now you do like wall
And then you
signs,
subtract
right?
60, divide by -2, and then you
Does it matter how I switch them? Does it matter?
Yeah.
Oh, that makes sense. I feel you. I'm gonna change all my B's and A's.
What do you mean? That was from the last problem. I just didn't erase.
No. Go back to the
And it also depends if you don't label A, B, C in the same order and you go in a different order, then obviously your equations wouldn't match mine. So that's why I generically try to always label isosceles ABC. Then you have a better chance if you follow the examples like mine that your work will look like mine. Feel good?
check it.
So what I think is really crazy about this is the fact that I get why we teach law of sines because of the special case scenario, but pretty much every oblique triangle can be done using law of cosines. If you have an opposite pair, you just plug it in for A and you're good to go, but law of sines is easier. It's more fun. That's a special case. All right, so on the board over here, just as a quick, hey, guess what? You have the assignment for law of cosines for tonight. Then you have, tomorrow we have a mixed review. We'll review for the test on Wednesday. That's the actual review sheet. And then Thursday will be the test, or Friday if you're not here Thursday. Please, if you're absent Thursday, I would not wait till after break to take this test. Come and see me on your lunch. Come and see me on your direct study / Rover block. Whatever the case, don't wait. You don't want to be doing law of sines come January. Special case. Yeah. Okay. Those of you that did not do your book work today, do it for tomorrow.
Oh, I do.
No, I got a person on there. Oh, I got the same thing.
So please don't never end up with the right answer.
Also,